pop up. Okay? So if we had this weird word equation, Harry wants to exchange pennies for dollars, Douglas infatuated silver things and will only exchange his dollar bills for silver objects. What does Harry have to do to get his pennies converted into dollar bills, and how many dollar bills can he get? So you may have seen questions like that in a previous math class, and you may have thought that those were kind of dumb, those don't make any sense, why do we need to bother to do it? The whole point of those questions is not because at some point you're going to encounter a Douglas that doesn't want to trade pennies for dollar bills. Okay? That's not the point of these questions. Okay? The point of these questions is to establish a process for you to be able to apply that out into the real world. Okay? So I'm going to do a little bit of soapboxing here. You're all sorts of complaints. Nobody ever taught me how to do my taxes. Mother effer, yeah, we freaking did. It's called mathematics. Okay? We taught you how to read the English language and how to process numbers. Okay? We did not show you how to do an exact problem because everybody's effing taxes are freaking different. You were trained how to do your taxes. Okay? You were. Okay? We didn't just do it for you that one time so that you could always do the exact same taxes. Because every freaking year, your taxes change. Okay? So what we teach you in the lower levels is not how to do a single process, but to give you the tools to be able to do multiple processes. Okay? So that just kind of came to me because I find that comment irritating. Oh, high school didn't train me for anything because I don't know how to do my taxes. It's because you didn't pay attention to what we were teaching you to do in class. Okay? So the idea is building a process. Okay? That is the whole point of chapter 2. Is not how do you do conversions. It's not how do you solve this question. Because no, you're not going to encounter a Douglas. Right? That's not going to happen. Okay? Unless we hit like apocalyptic times. Okay? Then maybe you'll encounter some weird guy that somehow survived and collected and hoarded a bunch of things and now will only trade for silver. Okay? That's just unrealistic. We aren't planning for that. What we're planning for is what is the process for how we solve these things. Okay? That's what you're attempting to do. Okay? And the reason for this is that we don't want you to go through and solve a question like this. What we want you to do is to have the skills to be able to do a conversion like this. Anybody know what the hell a Snorlax is? Or a Skittlefart?
Made up words.
Yeah, they're made up words. Okay? They're completely made up. You have no context of what they are. In this case, they're literally completely made up. It just happened to be whatever I happened to randomly think about while I was writing something down.
You thought about Skittlefart?
Have they not spent any time with my like a view into your world?
Taste the rainbow. Thanks, Ronnie. Yeah, I got you.
The point behind this is to get you to acknowledge that when you move further through life, you are going to encounter things and unit systems that you don't understand. Okay? Right after spring break, we're going to be talking about units that you don't understand. That for all intents and purposes are Skittlefarts to you. Okay? It's going to take a long time for you to be able to process what that actually means. Okay? In the case of Skittlefarts at multiple levels, you could try and figure out what that actually meant. Okay? Because that processing time is difficult, what we need is some method that allows us to work with that unit, even if we don't understand it. Okay? That's the point of the methodology. Okay? And this is something that I've been seeing with a lot of students, both past semesters and this semester, don't want to use this method because it's longer than what they learned before. Because what you have before was an algorithm to solve one question, and it only works to do that one conversion. If I ask you to do other conversions or stack multiple conversions, your method will fall apart. It's just a question of when it falls apart. Okay? So that's the point behind the method that we've talked about. Identify what you want, right? Identify what you're given to start with, and then just start trying to make that happen. Okay? And one of the next reflexes is we immediately want to throw numbers at it. Numbers aren't useful if you don't know where to place them. Okay? So you have to be thinking about numerators and denominators. And the only reason you know where to place those numbers is because of the units that you're dealing with. Okay? So the units are the most important aspect. Does anybody actually want to go through and solve this with the formal method? Sure. Okay, that's probably a good answer because it's only going to get more difficult. Okay? So, step one, what do we want? $1 bills. Okay? Thinking of writing systems, do we really want to write out DOLLARBILLS? No. So what do we do? We could do a DB, we could do a $sign. We come up with some symbol that allows us to shorthand that information.
Because writers and scientists tend to be lazy.
Yes. Okay, what are we given to start with? And arguably we're given a lot of stuff to start with. Okay, and this is one of the things that we have to think about, is what do we want to start with? Okay, why do you want to start with pennies? Okay, it kind of framed from the question. We're talking about Harry converting to dollar bills. Well, what does Harry have? Pennies. So we'll start with pennies. Okay, and I heard 100 pennies come out as a second statement. I would argue saying 100 pennies is false, saying pennies was good. Okay, I want the unit first. Once I know the unit, I can deal with it. Okay, where do I want that unit to be placed of pennies? Okay, to the left of the equal sign, I'll accept that. Should it be in the numerator or the denominator? Why should I place it in the numerator? What is pennies a measurement of? Currency. What is dollar bills a measurement of? Currency. Where's the dollar bills located in the answer? Where's dollar bills located in the answer? Numerator. Where should pennies be in our work? In the numerator. We'll match the measurement system to the location of where we want it to end up. How many pennies was I given? 100. Okay. Ideally, what happens? Pennies to dollar bills. And you go, well, I know how to do that. No, we don't. How can I get pennies converted into dollar bills according to the context of the question? The only person that has dollar bills is Douglas, and he ain't trading pennies for it because pennies aren't silver. So I don't have that conversion. I can't do it. So what do I have to convert the pennies to? Dimes. Do I know that conversion? Yeah, what is it?
10 pennies to 1 dime.
10 pennies to 1 dime. Where does the 10 go? Okay. I understand why you want to say bottom, and I'm going to say wrong. It needs to go with the pennies. Okay. If we start placing our numbers numerator-denominator base, if we change the context of the question, the number can change its location. So don't base the placement of your numbers on numerator-denominator. Base them based on the units they're tied to. 10 pennies equals 1 dime. Is dimes the same thing as dollars? No. So what has to happen?
Convert dimes to dollars.
I need another conversion where dimes needs to show up in the denominator so that,
You get dollars.
not so that I can get dollars. Okay, let's backtrack. Why did we place pennies in the denominator? So we wanted the units to cancel out. Why did I place dimes in the denominator in this calculation? So that it cancels out. Okay, that's the intent of that placement. What do I want those dimes to become? Dollars. Do I know the conversion factor that relates dollars to dimes?
10 dimes to $1.
10 dimes to $1. Where does the 10 go?
With the dimes.
With the dimes. Okay, what happens? What unit would I be left with?
Dollars.
Dollars. So now what can I do? Now I can manipulate all the mathematics to go through and solve. Okay? Yes, you could have done all of that calculation in your head. The point is not that you know how to do the calculation. Okay? Literally anybody can punch numbers into a calculator. That is not what we're trying to learn here. What we're trying to do is establish that process. Once we have the process, the idea is that you can match that to the calculation that you ran in your head and be like, did I get the same answer? If you did, what does that mean about the process? It's a good process. This is now trying to build confidence for you in the process. That's it. Right? That's what I want out of this section. Do you trust the process? So that when the unit systems change to something goofy like Snorlax and Skittle Farts, you can now trust that process to get you through with that conversion. Okay? And even in this example, it isn't that bad because we still have some pretty whole number conversions. Okay, up at the top. Those conversion factors were things that were given to you, so it's just a question of you applying. Should we try and solve this one?
Yeah.
Same deal? What are we trying to get to?
Skittle farts.
Skittle Farts. SF sounds good to me. What did we start with? Snorlaxi, we'll go with SN. Okay. How many Snorlaxi did I start with? 100. Are Snorlaxi the same thing as Skittle Farts? No. So what do I need to do? I need to do a conversion. In that conversion, what needs to show up? Where should the Snorlaxi show up? In the denominator. What else should show up? Ideally, what shows up?
It would be Skittle farts.
Ideally, I get Skittle Farts. Do I have that conversion? No. Since I don't have that conversion, what can I do? Now I can convert to dimes. What is the conversion factor between Snorlaxi and dimes? 8 dimes is 10 Snorlaxi. Where does the 10 go? Snorlaxi. Where does the dimes go? Or the 8 go? With the dimes. Okay. Are dimes the same thing as Skittle Farts? No. So what do we have to do? Convert. In that next conversion, what do I want to have happen? Dimes to cancel and Skittle Farts to come back. Do I have that conversion? Yeah. What's that conversion?
3 dimes to 1 Skittle Fart.
1 Skittle Fart, 3 dimes. What happens to the units? Dimes cancel. What would I have as a unit? Skittle Farts. By the way, this is the straightest face I've ever had solving this question. That's amazing.
Trying not to be a junior high right now, just saying.
Okay. Kind of makes sense? So what do you guys think? Think the process is somewhat decent? Potentially use it? So let's make it harder. Okay.
You didn't answer.
What was the number? So, and again, people will ask, I want the number. I don't care about the number because the number is punching it into the calculator. Okay? On a multiple choice test, eventually you do need to punch it in the calculator, multiply everything in the numerator, multiply everything in the denominator, divide numerator by denominator, and you have your answer. Okay? We'll do it for the next one because this next conversion is a little bit more complex when you enter it into the calculator. With that other one, they were pretty much whole numbers, so it should come out pretty cleanly. Okay? So we've got our process. Step 1, write the unit we want. Step 2, write what we are given to start with. Step 3, start using our conversion factors. Okay? This is a question straight off of exam 3, mostly. Okay? I had to add a whole bunch of extra stuff. Okay? How many seconds of molecules of caffeine are in 0.0350 grams of caffeine? Okay? This usually throws a wicked curveball at people because nobody has a clue what the hell a Sagan is. Okay? Anybody know what a Sagan is?
Made up word.
It's actually not entirely made up. I Googled weird powers of 10, is I think what I looked up. Okay? And Sagan happens to be one of them. Okay? A Sagan happens to be the predicted number of galaxies in the universe. It's something like that. Okay? Named after Carl Sagan, okay, famous author and physicist. Okay? So I want to know how many seconds of molecules are in caffeine, and in particular a 0.035 gram sample of caffeine. Okay? In this, what am I attempting to solve for? Okay. Is it really just seconds?
No.
Seconds per gram?
No, seconds of molecules.
Seconds of molecules of caffeine.
Now that's specific, I like it.
Okay? That's pretty nasty as a unit goes. Okay? So we might attempt to come up with approximations to simplify that. Okay? That is ultimately on you to decide how you want to do it at this stage. Okay? What are we given to start with?
You're given
grams.
0.0350
Okay? This one becomes challenging. Grams of caffeine is a measurement of mass. Seconds of molecules, that's a counting feature. That's actually not a mass. How would I know where to place my mass, numerator, denominator?
You have a 50-50 shot.
There it is. And this is where conversions become challenging, is you come up with, oh, this is how I do it. It's a 50-50 shot. Most of the time on a 50-50 shot, you end up being right in the homework. And so you go, oh, I totally trust the method. And then you get to the exam, and guess when the other 50% of the time shows up? On the exam, and you start misplacing those things. If you don't know what you should start with, then maybe grams of caffeine isn't the best thing to start with here. You might be, well, isn't that the only information given to me? Is it? 1 second of molecules of caffeine equals 4 times 10 to the 9th molecules of caffeine. 194 grams of caffeine equals 1 mole of molecules of caffeine. Okay, 1 mole of molecules of caffeine equals 6.022 times 10 to the 23rd molecules of caffeine. That may not say Snorlaxy, and those may be words that you're like, haha, those aren't funny. That's not a Skittle fart. Okay? But do you have really any comprehension of what those words are? Any more in depth than what a Skittle fart is? No. Okay? You may have heard some of these words before, so you don't laugh at them. You probably also don't laugh at them because you're like, oh, I have to actually solve this now. Okay? This isn't just Mike making words up. Okay? You're responsible for putting this together. Okay? And this is where if we think about what we've been doing in English, organizing our thoughts to help us go through and solve something. There's a lot of given information there. Which of those pieces of given information should I start with?
You should.
What do you think?
You should convert the grams of caffeine to the mole of molecules of caffeine.
Okay, so one option is saying, well, I'm going to start converting the grams of caffeine into the moles of caffeine using a conversion factor that I found up there. And I'm fine with that. Okay? But what you've done is now solved one step. Okay? Should you convert to days? Can I convert minutes, or sorry, let's do something we can do easier. Hours to days. Yeah, I can convert hours to days. Should I use that here? Why not? Okay, it doesn't make sense. It's not relevant to the question. In your solve, I'm not saying you're wrong necessarily, but why are you doing that conversion?
Because we need that in order to, because that's what.
How do you know you need that? Just because it's given, I could also write 24 hours equals 1 day. Does that mean I need to use it? Okay. So we need to be a little bit cautious in just starting to convert. We need a logic behind why we're doing that conversion. Okay? And I like where you went to. You went to familiar things. You saw grams of caffeine and said, oh, there's grams of caffeine up here, and I could convert that into moles of molecules.
Don't we need that, though? Because...
And I'm still not going to dispute that, but the question comes from what you are propagating out to see that. Okay? And so what you might be able to do is you're seeing 3 steps ahead. Does that mean everybody in the class is seeing 3 steps ahead? No. Okay? So what we need is a better system to be able to focus on and see what we've got here. Okay? So I want to take a step back from solving and think back to the writing system aspect that I want in this. Okay? All of that information is jumbled together, right? Could there be a better way to organize that information instead of just a random mass of pictures? Could we potentially sequence those so that they made more sense and pull the information out that we see from each of those pieces of images? Okay. Instead of running it all in one line, maybe, just maybe, I should split it out as separate systems, separate equation formats that would allow me to interpret this. Okay. Does anybody actually want to write out, let's do the longest one, Sagans of molecules of caffeine?
No.
Okay, no. So what might we write out instead?
That's how
Okay. So we could change that now to, I guess I should have had more fun with this. SOMAC. Okay. We could do that. If we're going to change that one to SOMAC, what are we solving for? What are we solving for? We're also solving for SOMACs. Okay. What were we given to start with? Grams of caffeine. Do you want to write out caffeine? What would you rather write out? C. Okay. Molecules of caffeine. Is that the same thing as a mole of caffeine? No, clearly not, because mole and molecule shows up at the same time. So what we're trying to do is come up with some way that we can simplify this. Moles of molecules of caffeine. We have GC. We have Mach. We have MOMAC. We have Mach.
Saying that in the context of an individual problem, it's okay for them to, in essence, kind of create their own writing system.
Absolutely. Okay. You should be able to create your own system to go through and solve. When we go through, what you will see typically is my writing system, the accepted writing system. For instance, for grams, do we see the symbol Z? Could you just as easily have picked Z for grams?
If we provide like a table or an index for it,
As long as you know that reference, you're okay. Okay. The other part of that is not only do you have to know that reference,
your reader has
people reading it have to know that reference, in which case that would be me. I have to know that reference. Okay? So you need to come up with some way to label that system so that everybody knows what's going on with it. Okay? So now let's take another swing at this question, because this is now SOMAC up here. What are we attempting to solve for? SOMACs. As far as what we're given, yes, we're given GC, and we could start with that. But does GC the same thing as SOMAC? No. Does SOMAC show up somewhere else? Yeah, where does it show up? Right there, doesn't it? Okay. So what I would argue is a good place to start is not with the grams of C, because why the hell am I going to use it? Should I place it in the numerator or the denominator? I don't know. Okay. If I don't know, I shouldn't start with that number because I don't know where to place it. Okay? So what I'm going to instead start with is that conversion factor of SOMACs. Okay, that blue one. Okay, where do I want SOMACs from that blue one to show up? Numerator or denominator? Why do I want it in the numerator?
Because it's the unit that you want to end up with.
I look at my answer, where does SOMAC show up? In the numerator. So where should it show up in the left-hand side? In the numerator. So I want SOMACs here. What am I relating the SOMACs to? Machs. What are the numerical arrangements or numerical ties to those units? 1 SOMAC equals 4.00 times 10 to the 19th mox.
10 to the 9.
You're right. Okay, cool. I've brought in SOMOX. That's fantastic. Do I have my answer?
No.
No, why not?
Because
I need to get rid of the mock. Okay? And what Joey just walked through was each of the individual steps. And I were to take a step back, then that's fine. I don't want mocks in my answer, so what needs to happen? It needs to cancel. So I'm going to go back to all the given information. Am I given just mocks? No. So what has to happen? I'm going to have to convert mock to momoc. Okay? Because that's the only place that it shows up. Okay? Yes, it shows up in the blue. If it shows up in the blue, what happens? I could reuse that and undo what I just did. Once I've used it, don't use it again. Okay? So I want mox to momox. Why do I want momoc in the denominator? Because I needed mox in the numerator so that it would cancel here. So momocs are now forced to go in the bottom. Okay? What numbers do I place? 22 times 10 to the 23rd in front of mox, which means? Goes up here. There's 1 momoc. Yeah? Okay. What unit would I now have? I canceled that wrong. Sorry. I have SOMOX and MOX. I only want SOMOX, so what has to happen? I don't know about you, but this is just as silly as Skittle Farts, just for the record.
It sounds funny you guys saying Momoc, SOMOC. Like it's like I'm hearing like a Star Trek episode about Darmok and Tanaka.
I want Momox to cancel, so it has to go in the numerator. Am I given just Momox? No. So where does Momox show up? To grams. So I'm going to put momox in the numerator so it cancels, and I'm going to place what in the denominator? GC. What numbers go with this?
So with momoc,
191.
1. What goes with GC?
194.
194. What happens?
Momox cancel.
Momox cancel. Awesome. I got rid of the problem, but I've created another problem. I now have GC in this. Do I want GC in my answer? No. So what do I need to do? Okay, I'm going to have to add yet another step in here where GC shows up in the numerator. Am I given just GC?
Yes.
Oh. So what would show up in the denominator? What unit?
Momoc, because you need.
If I put SOMOC in the denominator, what happens? It would cancel
So
out.
you just put a 1.
I would just put a 1. Okay? I don't want a unit in the denominator because if I put a unit in the denominator, it can potentially cancel. Okay, so the ideal circumstance is there is no unit down there. Right? Am I given just GC? The question says I was given 0.0350 GCs. What number shows up in the denominator? 1. If it's a number other than 1, it's not 0.0350 anymore. Right? If it's a unit other than no unit, it's not just grams of C. I'm relating it to something else. In this format, I've incorporated each individual unit of information in its own section. I have not crossed different streams. And I now have an ability to cancel all those units out. Okay? Let's backtrack through what you were the only one that volunteered, so thank you. What Haley suggested earlier on. So we wanted to start with grams of C.
I did the problem like that.
Okay. Why start with grams of C? Wanted to place it in the numerator. Is that where we placed it?
Yes.
Yes. Why was it placed in the numerator at the very beginning of the calculation?
Because that's what you're starting with. You don't know.
It was a 50-50 shot.
Well, okay.
Okay.
If you tell me I'm wrong, that's good. My reasoning for putting it in the numerator is because I went and I read that you had grams, so you know you need to put that in the denominator to cancel that out because all of the other things. Does that make sense?
So yes and no. So your reasoning for placing it in the numerator was that you knew that grams needed to show up in the denominator here so that it would cancel out.
Yeah, because then
But then you would get momok. So then
Yeah.
you knew that that happened.
Yes.
And then you knew that that happened. So what you knew to start with this was because you knew this, and this before they were written down.
Well, I knew that because I read the other.
And I'm fine with that.
Okay.
I am absolutely fine with that.
I just did it in my.
Right? Because I can tell you what more than likely happened, and this is based on my observations of how people solved, is you started with that number in the numerator because you're used to placing things in the numerator. And it also happened to be the first number you saw. If I switch up the order in which this information is given, for instance, if I give you the 194 grams equals 1 momok, guess what shows up in the numerator? 194. Should it have shown up in the numerator? No. And you end up solving for it backwards. Some people are awesome, and that may be your case. I'm not saying you aren't. Okay? You can do that all in your head. Most people cannot. And what they fall back on is there's a number that somehow needs to be converted. It's the first number I saw, so that's going to be the first number I work with. Okay? When you sign up for classes, you pick a class, right? Okay? The next class, you eliminate possible options because it conflicts with the first class, right? Okay? Couldn't you have changed the first class? Okay? And yet what happens? When you go through to sign up for classes, I've watched people sign up for classes. Your very first class that you picked dictates the rest of your schedule. Okay? Even if that first class was not a good class for you to take, you're now basing your entire schedule off of the very first thing you did. The same thing happens with conversions. Okay? We need a solid reason for why we are starting with that particular piece of information. If you don't have a good rhetorical reason for why you're starting with it, the whole system crumbles, and you're relying on blind luck for you processing through the rest of the information. Okay? When it's a 50-50 coin toss, that's where it becomes problematic, because guess what happens? Half the time you're right, and you're like, oh, sweet, I totally know what I'm doing. And then the other half the time you're wrong, you're like, oh, I must have made a math. Oh, that's how I did it. No, you just guessed. That's okay when you get it right. Okay? What I want you to do is have a process that doesn't involve any guessing. Okay? In this first section, you're dealing with units you've already seen before, okay? Which means you've already built in a system of automatically locking in those spots. Okay? All I want you to do is pause and say, why did I place those things in those locations? Okay? If you watch an advanced chemist or tutor go through and solve, they will always start with this grams of C. They'll always put that in the numerator. Okay, why? They've solved hundreds of questions, and what they've found is that it works best being placed in the numerator at the beginning. How many of you have solved hundreds of questions? So that's a crap method to follow. Okay? The only reason they're doing it is because that's how they've been trained to, and they've seen that it always works. If you haven't done that, you need a better system than just saying, well, it always works. Make sense? Okay? So when you set up your work, track what you know to work. Okay? In this system, you're given all of these conversion factors. Okay? You have to be able to apply how to use that information. That's this unit. Okay? Can I delete all that? Okay. Because here's what the next unit is. Actually, no. That was bad. That's the next unit. What all of a sudden happened? You lost information. Did you actually lose it, though? This piece of information, we actually already had in the room. You just didn't know that it was there. You already have that piece of information. I just made it explicit. Okay? In the next unit, you have to know where to find that information. Yeah. Grams to moles of caffeine is already in this room. Have fun finding it. Okay? The moles of molecules of caffeine into the molecules of caffeine, that is a conversion factor that you are required to memorize in the next unit. Okay? So the next unit is now not going to be just how do you solve these questions. The next unit is, can you recall where all of this information is found and now put it all together into a solve? Okay? That becomes significantly harder if you don't have a process on which to base it, because now you have to apply the process and those memorization skills. Make sense?
Right now, Mike is asking you to do analysis. In the next unit, you're going to use this process of analysis as a baseline to determine research questions. What do I need to find? Then you're going to have to go do the research, and then you're going to have to synthesize that information with your current analysis and complete the analysis. It gets much more cognitively complex.
In these solves, I will still see people, I'm guaranteed, on the exam to break each of those little conversion steps down. Okay, we did, what do we had? 1, 2, 3 conversions lined up here, all run simultaneously. Guaranteed on the exam, someone's going to break it down into each of those individual steps and try cross multiplication. That is a phenomenal, simple process for one conversion. Most of what we do in this class is not a single conversion. There's multiple. So by setting up those equalities and those proportionalities, it's only going to hurt you in the long run because you now have to run multiple approximations or multiple cross multiplications. Okay? So the idea here is to get used to this process and recognize the power of it so that you don't have to do those multiple equality cross multiply stuff. Okay? So, how do we do this conversion? I'm a little bit nervous I pulled open the wrong slideshow. In fact, I'm positive I pulled open the wrong slideshow. So, nope, I didn't. So, we're just going to look at this one. All right, did we see this side? No? Okay. An automobile engine displaces a volume of 498 centimeters cubed in each cylinder. What is the displacement of the cylinder in cubic inches? What are you being asked to solve for?
The displacement of the cylinder in cubic inches.
So I'm being asked for cubic inches. What am I given to start with?
498.
Cubic centimeters. Not 498, I'm given cubic centimeters. Okay. What is the number associated with that? 498. Why can we get away starting with 498 centimeters cubed in the numerator? There's only one piece of information given here. This is why we get used to placing that first number directly in the numerator. Okay, this becomes the problem. Just because it's the first number doesn't mean it should get placed there. Okay, what is the reason for why we're allowed to place it there? Centimeters cubed is a measurement of? Okay. If it's length, it would just be centimeters. That's the centimeters cubed. This is length times width times height. This is a measurement of volume. What is inches cubed a measurement of? Also volume. Where's my inches cubed in the answer? Numerator, denominator? Numerator. So my answer, I want volume in the numerator. My starting work, where do I want volume to show up? Numerator. That's why I can place that centimeters cubed there. Okay? It's not because it's the first thing I'm given. It's because I'm asked to solve for volume. I'm starting with volume. Okay? Is inches cubed the same thing as centimeters cubed? No. So what has to happen? I need to do a conversion. Centimeters needs to become inches. Are you required to memorize that? No. No, you are not. You may have memorized it, that's fine, but no, you are not required to memorize that. Okay, 2.54 centimeters equals 1 inch. Okay, how would we know whether or not we were required to memorize that? Look at the front of the exam. It's on the front of the exam. You're not required to memorize it. Okay? So centimeters to inches. But am I converting centimeters or centimeters cubed? Centimeters cubed, which means, is that a correct conversion? No. What needs to happen? Okay? So we'll hear a couple answers. It needs to be cubed. Okay? And now when we go through to solve this, we take 498 and we divide by 2.54 and we get the wrong answer. When we cube it, we're cubing everything. What is 1 cubed? What is 2.54 cubed?
Give me a second.
Yeah, give me a second. It's not 2.54. Okay? So I would take a step away from just saying, well, I'm going to cube it, because if you just cube it, you're probably going to do it wrong in the calculator. Your work may show it correctly, okay, as long as you drop those parentheses in there, but what you enter the calculator will physically be wrong. That cancels one of my centimeters, and it becomes centimeters squared. My answer would be inches times centimeters squared. Is that what I want?
No.
What do I want? Inches cubed. So what has to happen? I have to do it again. 1 inch is 2.54 centimeters. Centimeters cancels. One of them. I would now have inches squared times centimeters. Okay, I need to get rid of that last centimeter unit. I do so by doing the conversion again. 1 inch, 2.54. That centimeters takes that unit away, and I now have inches cubed. So when I run this calculation, it's 498 divided by 2.54, divided by 2.54, divided by 2.54. Okay? By breaking those exponential things out into the individual conversions, you can minimize the odds of making a simple calculator mistake. Does that make sense?
Could we use our calculator to just cube that 2.54 from the gauge, so we don't have to do the same step 3
Right.
times?
So if we break this out, 498 centimeters cubed, could you have gone through and said 1 inch, 2.54 centimeters cubed equals? Yes. In black, that work is perfectly valid. That's true. The issue becomes how you enter it in the calculator. So all I'm spelling out within the work here is to minimize the odds that you screw up the calculator. If you don't screw up the calculator, either of these forms of work are fine. Does that make sense? Okay. So you can enter into the calculator 2.54 cubed and then do the math or the division. That's okay. Okay. The odds of you making a mistake there increase. That's why I would break it down. And that's the only reason I break it down. Does that make sense? Okay. We good? Okay. Okay. Our double replacement reactions, okay, you are required to predict these. So given both of these text-based things, you should be able to write down their chemical formulas, predict their products, and balance the equation. Should we walk through them?
Yes.
Barium chloride. What should we write down?
BACL.
BaCl. AQ. What should I write down next? No.
No, plus sign.
No. So for those of you watching at home, an arrow and a plus sign are both wrong.
Should be a 2 next to a point.
Okay, you've jumped a step, and I'm okay with that. The next thing we should be writing down would be the charge on barium is a +2, the charge on chloride is a -1. Is that formula actually correct? No. We would need to fix that formula. How do I know barium's a +2? Kind of, sort of, you're supposed to memorize it.
It's in the second.
It's in the second group. The second group you're required to know is a +2. Chloride's a -1. How do I know that?
Because your noble gases are 0 and move 1 back.
Okay. Chlorine is in the halogen, the second to last column. We're required to know that those are all -1. Okay. You can go through on your periodic table as soon as you get it, just write the charges across the top as soon as you get the exam. Cool. You now don't have to memorize it for the rest of the exam. You just have to apply that knowledge. Okay, but you will have to apply it. So this needs to be BaCl2. I need 2 chlorides to balance out the barium. Okay. Reacts with, now it's a plus sign. Okay, it's not an arrow because it's saying reacts with, okay, potassium chromate. The plus sign at that point was wrong. We started to continue on into writing out the equation before we had the proper formula. Okay, now that we have a proper formula, now we can continue to process the rest of the statement. Reacts with is now a plus sign. Aqueous is our phase, which we can throw in at the end. What's the symbol for potassium?
Okay.
Okay, what is the symbol for chromate?
CO.
Are you required to memorize it? No, you are not required to memorize the chromate. Go back and review those 7 things from the nomenclature video. I told you to memorize 7. If I asked this on the test, there's probably some sneaky underhanded thing that I'm indirectly telling you, preventing you from even needing to answer that or know that information. If it does show up and you're like, I need to know that, raise your hand because I will give that information to you. Chromate is CrO4. Okay, we can add the aqueous. Now what? Charges, good. Potassium is a +1. Chromate is a -2. I give that information to you. Is that formula correct?
No, we need to change it to K2.
I need 2 potassiums. Okay? So I'm now mixing those 2 things. Those 2 things potentially react. How would I know that's a double replacement reaction?
We need to switch around.
How would I know it's a double replacement?
Because of,
If you have two chemicals plus 2 chemicals.
2 chemicals, or 2 pieces, cation, anion, cation, anion. I have 2 cation anions. The only one that matches that is the double replacement. That means I should be going through the double replacement reaction. I'll exchange the cations for each other, which means I will get potassium with chloride, and I will get barium with chromate. That's now following the double replacement. Okay? This said K2CrO4. Should the 2 come across?
No, because
Why is the 2 next to the potassium?
it's reacting with the chromate.
With the chromate. Is the potassium with the chromate anymore? No, so you can't put the 2 there. Okay? I'm not saying the 2 isn't necessary, okay, but you can't place it there for that reason. You have to know why those numbers are present. Okay? For that same reason, if we take a look at the chloride, there's a 2, barium Cl2. Why is the 2 next to the chloride in barium chloride? To cancel out the barium. Is the chloride with barium in the product? No. So don't bring the 2 across for that reason. Okay? What is the charge on potassium? +1. The charge on chloride? -1. Is that formula correct? Yes. So no 2's come across. None at all. No 2's come across. Okay? We move across to the barium chromate. What is the charge on the barium? A +2. What is the charge on chromate? A -2. Is that formula balanced? Yes. So that is a correct formula. Now what should we consider?
The amount of each element.
I know where you're going. I want the name for that process. Not phases yet. Arguably, the order isn't going to matter. I want to balance the equation. Is the equation balanced? No. We have 2 potassiums and 2 chlorides on the left-hand side. I only have 1 of each. So what can I do? I can put a 2 in front here on the product side. Now I have 2 potassiums. I have 2 chlorides. Those are balanced. Are the bariums balanced?
Yes.
Are the chromates balanced? Yes. Okay. With the equation balanced, now I can potentially move on to the next question. When we go through and look at these, Yes, we have to predict the products. We also have to be able to predict the phases for the double replacement reaction. Okay? To predict the phase, we have to know some more information. What information do we have to know? The solubility rules. If you don't have the solubility rules memorized, then you should probably look at the front of the exam, because the front of the exam has some solubility rules. You need to be able to apply those rules. Okay? As far as memorization goes, I've only got some of them memorized. Anything with a group 1 metal is soluble. Okay? I know soluble begins with S, but we're saying soluble in water. If something dissolves in water, what is the phase of that system?
Aqueous.
It is now aqueous. So soluble means aqueous. So I know potassium chloride is aqueous. Right? I have to apply that rule. That is a rule that I have memorized. You may choose not to. That's up to you, but you still have to use the rules. Right? What is the phase on barium chromate? It's going to be a solid. So why is it going to be a solid? I know where you're looking.
Because it says that chromate ion is insoluble.
If we go to our solubility rules, we can find chromate. And when we look at chromate, chromates are usually insoluble, which means they don't dissolve in water, which means they're solids. Okay. What if you didn't have the solubility rules? What else could I add to this to actually ensure that you knew that you needed a solid there? What's that?
For example,
Unfortunately, I can't use that.
Is it the
It's really simple. I have to give you more information. That more information is a chemical reaction happens. How do I know a chemical reaction has happened?
did you say it reacts?
That's in quotes. I'm now saying a chemical reaction has happened. Given that equation, how would you know a chemical equation has happened or a chemical reaction has happened? Nope. The arrow is what we've written as a chemical equation is this is what would happen. Okay.
And produce an insoluble substance.
Okay? It's producing an insoluble substance. So this goes back to right at the beginning when we talked about chemical reactions. How do we know a chemical reaction happened? The first two rules were a change in phase, the formation of a solid or a gas. If I tell you a chemical reaction has happened, if this one's aqueous, what does this one have to be? A solid or a gas. Okay? It cannot also be aqueous. When we're looking at our double replacements, they're typically forming solids. Okay? So what you need to be able to do is to use that extra information. Either I tell you a chemical reaction has happened, or you use the solubility rules. You have to be pulling information from those. If you aren't pulling information from those, you're guessing. Okay? Again, 50-50. It either is or it isn't. Okay? That's all we do is a collection of 50-50 questions. Okay? So, you have a condensed format. You'll see something like this. I think that's way too much to include, so I only include a couple. Okay? You'll notice that I did say that I have memorized some of these. The ones that I have memorized, the first 3 rules. Why would I have memorized the first 3 rules and none of the others?
Because that's
Because
what
it's easier to know the charge.
There are exceptions.
Every other rule
has
has exceptions. I'm not going to bother to memorize a rule that has exceptions because then I have to memorize the rule
And all the exceptions.
and all the exceptions. That's too much effort. So I will just memorize the ones that don't have exceptions. Okay? And then hope that whoever's testing me on this has the wherewithal to recognize that they should probably be giving me the things with exceptions. Okay? Make sense? Okay. Let's take a look at that barium chromate. So on using this, We're looking for either of those ions, barium or chromate. Barium's a group 2 metal, so it doesn't satisfy rule 1 because it's alkali metals. That's column 1. Okay. Acetate, it's not acetate, it's not nitrate. Halide ions, I don't see barium show up at all. Oh, in rule 5, barium shows up. Do I care about rule 5? Why not?
Because it's mixed with sulfate.
That's barium with sulfate, not barium with chromate. So what I'm going to do is just continue to read through until I find either of those ions, barium or chromate, to identify the rule. So in the case of barium chromate, what rule am I looking at? Looking at rule 7. Okay, and it just says chromate, and then it says exceptions. What the hell? How does that mean it's a solid?
It says it's insoluble.
Okay. There's a reason we have a header on top of it. That header says that the following are insoluble in water. Okay. Because chromate is under the insoluble category, I would expect those to then be solids. Okay. The exception to that, which would then mean
Is that if it's combined with lithium?
yeah, and those would then be aqueous. If we look at rule 1, the reference is now that they are soluble, which means aqueous. We also encounter some exceptions. Those exceptions are now solids. Our analysis inverts because we're using a different header to describe what's underneath. Make sense? Okay. James, I know you had a question. I kind of talked over you.
No, you answered it. I was
Okay.
going to say, so if it's, so for chromate, if it is with lithium, then it is soluble.
Then it is soluble. Exactly right.
Would you make it AQ as opposed to?
Yes.
Okay.
So if we looked at chromate, let's not do lithium, let's do potassium. Potassium is a group 1 metal. According to my rules, we might say, well, chromate's insoluble, except for rule 1.
If it's partnered with that.
We're done at 45, right?
Oh, yeah, you're right.
Yeah,
Sorry
never
about
mind,
that.
just checking.
We
Chromate,
have an exam today, so if you can
Okay.
stop before 9:45, that'd be great.
I don't start them before 9:45, okay? Our exceptions are that they're soluble, okay? Our alkali metals, okay, is our exception. Potassium's an alkali metal. So I actually don't even need to know the rule for chromate, for potassium chromate, because alkali metals, rule 1. I don't care about the rule for chromate. I look straight to rule 1. Okay? Make sense?
So, are you saying that you memorized the first 3 rules? Are we going to be required to do the same?
Nope.
Okay.
All you gotta do is take a look at exam 1. Or even, yeah, you can look at exam 1. Very first page, it gives you the solubility rules. Okay? For the second equation, did a chemical reaction happen? Okay, so let's pause for a second. Let's go through some of the answers that were shouted out for deciding if a chemical reaction happened. One of the answers were, it was a double replacement. Is this a double replacement?
Yes.
Yes. Okay, so according to that rule, you're saying a chemical reaction has happened. Another answer, there was a reaction arrow. According to that rule, a chemical reaction has happened. I said both of those were horrible statements to make. How do we know a chemical reaction has happened? A change in phase. Aqueous, 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 aqueous. Did we change the phase? No, which means no chemical reaction happened. Okay? Our chemical equations are predictions on if a chemical reaction happened, this is what we would see. Okay? The phases actually add that extra information in. This is one of the reasons why you're supposed to always include phases, because the phases now stand up and say, hey, a chemical reaction happened, or nothing happened. Okay? That's why we need to include phases in our chemical reactions, okay, or our chemical equations. Okay? Neutralization reaction. Does that format look familiar at all to anybody? a little bit.
Yeah, I'm like,
It looks kind of like something we may have just literally talked about. AB plus CD, AD. So we went through AB plus CD. A goes. Oh, look at that. Guess what a neutralization is?
hydrogen atoms.
It is a double replacement. Okay? Which is an interesting one because colleagues are like, why do we even talk about neutralizations? They're just double replacements. Yes, they are. Why do we separate them out as their own category?
No phase change.
What's that?
No phase change.
There is actually a phase change. I haven't specified that in this equation. We start with aqueous things. The phase change H2O is not aqueous. We wouldn't say it's dissolved in water. It is water, so it's a liquid. So we do actually see a phase change here. Okay? And this is a chemical reaction.
Because it has to do with acids.
Why might that be important? How many of you knew acids were dangerous before chemistry? Oh, wow, there we go. Acids and bases and neutralization reactions in general are referenced not because they're their own distinct category for double replacement, but everybody has some of that context already. Acid-base reactions are amazingly old because they've been around for so long, they got their own category. Okay? And for those people going, well, that's silly, why would we ever do that? To that, I would just ask, what is the name for H2O? Why is it not dihydrogen monoxide?
Water sounds funny.
Because water was the first name associated with it, or an older name associated with it. We still have carryovers from old, long dead people. Okay? That's why we talk about neutralization, is it's an old class of chemistry. We're still referencing it because it still has relevance today. Okay? It's referencing those acid and base reactions that we're already familiar with. Okay? When we run an acid-base reaction, okay, or a neutralization, we must have an acid. How do we know it's an acid?
Hydrogen.
We have hydrogen. Is that it?
Is it aqueous?
Okay. It should also say aqueous. Sorry, that was a bit sloppy. Let me try that again. Does that compound satisfy both of those rules? Does it have hydrogen and is it aqueous?
Yes, it does.
Yes. It has hydrogen and it is aqueous. Is it an acid? No. So our rules were wrong. Which is why I think you were...
Yeah, the hydrogen has to be different.
Okay. For you guys to identify an acid, where must the hydrogen be located? The very first thing. Okay. Why might we include it as the very first thing?
To signify that it is an acid.
To signify that it is an acid. Why would I care? How many of you knew acids were dangerous? Oh, that's right. We're trying to call attention to the reactivity of the species by putting that out front. Okay, that's the only reason. Okay, so when we're looking for our neutralizations, we need to see an acid. Hydrogen in front and AQ. Okay, once those things are satisfied, we're probably looking at a neutralization reaction. We do have to be a little bit careful to make sure that our base includes hydroxide, so OH. The products will always be a salt, okay, and not with batteries. And water. That was a bad joke.
It's associated.
So let's take a look. Predict the product of a complete neutralization of sulfuric acid with potassium hydroxide. How do I know, where do I start? Hydrogen's a good place to start, because I start with it. Okay? So what's the rest of it for sulfuric acid?
SO4.
Okay, SO4. What is the charge on SO4? -2. What's the charge on hydrogen? +1. Is this formula correct? No.
H2.
I need 2 hydrogens. H2SO4. What else do I need?
Just state that it's aqueous.
I have to state that it's aqueous. Okay. Plus, potassium is
Okay.
K. Hydroxide is
OH.
OH. What is the charge on potassium?
1.
Charge on hydroxide? -1. Is that formula correct? Yes. Okay. Officially, I should have said aqueous potassium hydroxide, so let's just pretend I did. Okay. What does it produce?
Potassium sulfate and water.
Potassium with the sulfate and water. I would argue you should write it out as HOH. Sometimes I'll even go in and show the bond like I've got shown here. Okay, and we'll address why here in a second. Is the potassium sulfate correctly written? Why not?
Because in order for it to be balanced out, we're going to need
You would need
What do you
two
mean,
po-
balanced out? You can jump in, James.
You need 2 potassiums.
Why do I need 2 potassiums?
Because potassium is +1, but
Thank you.
sulfate is -4. Or -2, I'm sorry.
-2.
Yeah.
Good
I-
catch.
I saw the 4 up there.
Okay, so I need 2 potassiums there. What is the charge on hydrogen?
1.
A +1. What is the charge on hydroxide?
-1.
-1, so that formula is correct. Okay. Is my equation balanced? No. How do I fix it?
Okay. And then it's
Okay. That sets me up with the 2 potassiums correctly now, but at the same time, that gets me 2 hydroxides. Okay. I only have 1,
You need 2 anyways because you need 2 hydrogens.
and I need 2 anyways to represent those 2 hydrogens. By writing out water as HOH, I can balance with the hydroxide versus hydrogen. It can simplify my balancing process. Okay, kind of makes sense? Okay. So cool, there's an answer. Our reaction types are combustion reactions. Okay, just as a general format, we talked about this. You're taking carbon, some unknown amount of carbon, doesn't really matter how much, with hydrogen. Sometimes you could see oxygen. Okay, that one's questionable, not a requirement there. To react, you must react it with oxygen gas. This will always produce CO2, gas, and H2O. What phase will the H2O be? Arguably, it's going to depend. Okay. Typically, it's written as liquid. So every time you run a combustion, you see water.
No, you see fire.
You see fire. Okay. If you put a watch glass or a piece of glass over the top of a fire, the next time you see a fire, what you will eventually see happen on the glass? Condensation. You will see liquid water come off it. All combustion reactions produce water. Have you seen anybody's car driving down the road and seen weird drops coming out of the back of the tailpipe? It's the production of water. Okay? So it is producing water. Okay? Depending on the temperature, you may see it as liquid. Most combustion reactions are really hot, which means what happens to our liquid water? Transitions into a gas, and so sometimes you'll see it referenced as a gas. Okay? So it all kind of depends on that context, on what someone's trying to play with. Don't stress about the phase on the water.
So because this was a reaction with material, we didn't add any heat, we don't need that delta above the line?
True. And so this one usually throws everybody for a little bit of a loop. We don't need a delta specifying that we've added heat to cause this to happen. We have added a spark. Okay? The spark is giving it enough energy so that it initiates the reaction. It is then self-sustaining, which means I don't have to constantly add heat. The delta symbol over the top of the arrow means I'm constantly adding heat to get it to go. Okay? That's not the case with a combustion reaction. All we've done is provided a spark. Okay? We'll talk about what that spark means much later in the semester, okay? Because arguably it's borderline on our content for this class. Other questions about our combustions?
So then, for that, if you said it kind of depends for H2O, sometimes it's liquid, sometimes it's gas. And
Yep.
I think you said you don't really need to specify, right?
The phase, yeah.
So if later on, if that appears in homework or a test or something, and we don't list the phase after H2O,
I'm not going to care.
oh,
Hi. Balancing the combustion reactions can be a whole nother challenge. That's what you saw within the video. relatively minor, so let's not stress about balancing those. But let's do a little bit of testing on your abilities. Okay? We got about 5 minutes, so let's see what we can come up with in 30 seconds. The very first equation is what kind of reaction? Okay, let's try that again. Our first equation,
That's combustion.
that would be a combustion, literally the one we just looked at. That's okay. You just look down lower. Okay, it's a combustion reaction. Are you required to predict the products of a combustion reaction?
Yes.
Yes. Combustion reactions, you need to know they produce CO2 and water. Are you required to balance the reaction once you have it?
Yes.
Yes, you're always required to balance once you have the reaction. So our combustion reactions are challenging because you have to predict products and you have to balance. Lithium metal reacts with bromine gas to produce. Why is this one more challenging?
Because we have to first balance it ourselves on the left side, the charges. Or, I should say balance.
To balance something, you need a left and a right. You
Yeah.
need a reactant and a product. Does this specify a product?
No.
No. Okay? So balancing is fine to think about. That is also the third question in this list. Before we get to that third question, we should answer the first two. How do we determine the reaction type?
With the phases,
The
Or
number
the-
and the number of elements.
their activities.
Okay. Remember we had a list of that sequence, right? So we're hearing activity series jump out there. If you say activity series, you're now saying it's a single replacement. Well, how do I know? Okay. So we're hearing a bunch of suggestions, so let's rechange this question. Should I be looking at an activity series?
No.
No. Interesting. You're the one that suggested I should look at an activity series, and now all of a sudden you're no. What changed?
You need the output.
Well, it's because if in order to have a single replacement, you would need 2 atoms of something.
To do a single replacement, we do have to start with a metal. So yes, lithium metal is okay, but then I need the next thing to be 2 different elements. Is the next thing 2 different elements? No, so this doesn't match the pattern of a single replacement. Because it doesn't match the pattern of a single replacement, don't use an activity series, because the activity series is only for single replacements. Okay? And yet, single replacements was a suggested thing to use first. Why? You read the English of the text, but everything you've learned about the equations is not in that format. We need to recognize what those genres are. What do they look like? We recognize those patterns by looking at the chemical equation. If given a bunch of text, you need to convert it out to the chemical equation so that you can then interpret some information about it, because that's your interpretive aspect. What kind of chemical reaction is that?
Combination.
It is a combination. Are you required to predict the products of combinations?
Yes.
Go back and review the videos, and you should review them very swiftly. No, you are not required to balance or predict combination reactions. They are too complex of a reaction. In general, combinations you should not be predicting, which means, as far as those lists of questions are concerned, we're done. Question 3. What kind of chemical reaction is that?
Decomposition.
We should jump all over decomposition. A couple people paused because you were probably, I got tripped up on that last one. Maybe I should write it out. I'm starting with one thing. There's only one reaction that starts with one thing, and that would be a decomposition. Why did you say decomposition without writing it out?
Because it says decompose.
Because it says decompose. Use the language to help you out with this. Okay, are you required to predict decomposition reactions? No. So don't. We can't balance that equation because I don't know what it decomposes into. Okay. 4. Sodium chloride reacts with aqueous lithium nitrate.
Double replacement.
Double replacement. Okay. Some people are now starting to pick up the patterns of being able to look at and come up with those formulas. Okay, or recognize that we just talked about it. Okay? You need to be coming up with that translation pretty quickly. If you aren't writing it down, you're trying to do that in your head. There's so much content that you will probably shuffle it all together. Write that information down. Okay? With that, we do have the exam Thursday. And yeah, I'll post the video so you got access to it. If you got questions,